In this video, I want to spend just a couple minutes to talk about the idea of a copy on write. So here what we're going to do is basically go back to talking about fork. So fork, hopefully you remember from before, the idea of fork was a function in Linux that if I use it, I use it basically in a process that's running. That process all of a sudden creates a child process, and that child process is going to be running exactly the same code as the parent. So this is pretty neat, right? It's something we've kind of used before. It's one way basically to get things running in parallel. Now one concern with this operation is that sometimes it can be too costly. It can be too costly because by default, what fork does is it basically creates the child as a complete clone of the parent. But this isn't always what fork is used for, right? And sometimes right, that is a good thing, right? That's what we want. But sometimes, right, a parent wants to do something like run an external program, in which case it needs to do a fork to create a new process. But then that new process really should be another program running. So if we do that, right, basically what happens is, and we think of a naive approach, just copy the child when we do the fork. Well, then I do that copy, and all of a sudden that copy gets almost immediately replaced with somebody else's code. So this is kind of a little bit problematic, right? It's a little bit slow. So we want to see maybe if there's a faster way to do that. And it is, right, I'll kind of answer that last point there, right? It is kind of the case, pretty often that I want to create a process in terms of spawning something else, right? That's kind of a very typical thing. Because a lot of times if a program is running and wants to do something in parallel, it can just create threads, right? Threads are lightweight, right? They're going to be associated with that initial process. So if it's doing the fork command, right, it's actually creating another process, typically it's something that's going to be completely different, right? It's going to be running different program code, and therefore if I do that kind of copy up front, right, it's going to be a little bit too costly. So let's see how we can maybe fix this. So here's an idea. When I create a child, I'll just have the child's page table reference the frames that the parent used. So we can look here, right? I have basically my parent over here, put my parent on the left, child on the right, and it's right the parent's running. It has different pieces of memory assigned to it, and it has the basically entries in the page table, which I'll point to basically different parts of physical memory. So basically like this, right? So this is kind of, I guess, this is sort of a page table. Right? This is sort of a page table. For the parent. The parent has these different things in memory. But what I can think about doing is for the child, just have the child look at the same memory that the parent's using. Right? So in this case, I have my page table for my child, and notice it's just pointing to exactly the same things as what the parent had. If I do this, it's going to be super fast because I'm not having to copy anything. Right? I don't have to duplicate memory. I'm just going to basically reference what's already there. Now, also we have, so this is kind of our first idea, right? Now, where does the name of this whole thing come from, right? We mentioned this idea of copy on write. What copy on write says is that a child basically is going to use the parent up until it does a write. So if it does a write on something, like for example at page C, what happens is the child basically makes a copy of it. And I guess it turns out actually that the child was on the left-hand side, so we'll kind of pretend those are flipped. When the child does a write to a page, only then will we make a copy of it. And so it's kind of like a lazy model, right? So we only copy that child process's pages into new discrete locations when they're actually needed, right? So when I actually need to have that new page because I've written to it, I've made my data unique from the parent, that's when I'll copy it somewhere else. Up until then, I'll just leave it alone. So this is kind of an idea of copy on write, right? It's kind of a nice way, right, basically to use a page table in order to have an optimized implementation of fork. The other note here is basically vfork, and vfork is kind of deprecated. You should not use it. Vfork is basically, it pauses the parent. So if you do a vfork, the child gets to run and do stuff, but it basically just pauses the parent and inherits everything. So the child basically has access to all the memory that the parent has, and there's kind of the assumption that if the child does that, they just have to be really careful because when they're done, right, they don't have any memory of their own. They're just using the parent stuff, and the parent will kind of pick up where they left off. So that's kind of a dangerous function. Typically, people are recommended not to use it anymore. So there we have it, right? That's kind of some ideas about how fork is implemented.